Hello, my lovely students. So we are now going to dig into what I would consider proper logic. So I actually first learned logic way back in the summer in the 90s somewhere in one of those geeky summer programs where you go to college and learn stuff. No one is surprised I was that kind of geek. But logic was one of the fun things we got to do. I really enjoyed it just because my brain really likes those analytical kind of puzzles and figuring out, how do I have to set this up and where do the pieces go and what would the order of the pieces be in? That's just my jam. So we're not going to get that nitty gritty into logic, but we are going to talk about the overall structure, what it means, especially with conditionals, because conditional statements people use all the time. So first we have a proposition, makes a claim, either an assertion or a denial that may be either true or false. Now that's not assertions are true and denials are false. Denials can be true and assertions can be false. I can fly. That's an assertion that is false. Or I can't do math. That's a denial that is false. Because everybody can do a little math. And I better be able to do it since I got a degree in it. Or a denial that's true. Well, I guess I can't fly would be a denial that's true. All right. Now, any of these propositions, now they're the structure of a complete sentence. So a question is not a proposition. A part of a sentence is not a proposition. So the red house. There's no verb. It's not a complete sentence. But the red house is over there. That is a claim that I can say that is true or false once I figure out what they're meant in the sentence. So it may not be easy to determine it, but there is a true or false value that can be assigned to the sentence. And in this case, we don't consider half truths or falses. We're just assume it's the kind of sentence that you can just say it is or it isn't, no gray areas. Now, ironically, math also has complete sentences. If I write 2 plus 5 equals 3, that is a mathematical sentence. And it is a mathematical sentence because of the equal sign. When you read words that you're supposed to translate into an equation, the verb ends up being the equal sign. So usually it's something like 3 pounds of oranges costs $7.50. So you would write like 3 pounds of oranges equals $7.50. And then you could figure out how much 1 pound of orange equals from that, doing some weird work. So the fact that the statement I wrote here, 2 plus 5 equals 3, is false, that's okay. It does meet a proposition because it is something that I can say is true or false. Now I could even do this with 2 is greater than 3. That's a false assertion, but it's a proposition. Not quite the same as right or wrong, just true or false, but pretty close to right or wrong. All right. So because any proposition has 2 and only 2 possible truth values, true or false. So sometimes we want to consider the negation of a proposition. The negation, and the way we write it is we either write out the word not in front of it, or we put a tilde symbol, which is in the top left of your keyboard. That's where both of the accent buttons are. So it's technically called a tilde. Some people call it a wiggle, which is more fun to say. So I might call it that. Usually though, I'll just say not P because that's the way you're supposed to read it from a logic perspective. So the truth value of not P is the opposite of whatever P is. So it can be something like Houston is the capital of Texas. The negation of that would be Houston is not the capital of Texas. So it's not answering what is the capital. It is just negating the sentence, writing a sentence that means the opposite. And generally, you just do that by shoving the word not where it makes sense grammatically. Now, in a logic standpoint, we write these things called truth tables. And so just the statement P can either be true or false. There are only two options, yes or no, on or off. This is literally the basis of computers. Like bits that are ones and zeros are trues and false. That's one of the ways to think about it. So in our truth table, if we only have one proposition, just P, then P only has two possible values, true and false. Now, not P, the negation of P, is the opposite of that. So if P is true, then not P must be the opposite, which would be false. If P was false, not P is the opposite of that, which is true. So what I have for P is all the possible values of P, and then I generated all the possible values of not P based on what P was. Now I can put multiple negatives. Logically, it looks kind of silly. Like we don't say negative, well, actually we do sometimes say negative too, but it happens a lot more in English. And there's quite a few examples in the book if you want to check them out. So we have not P, and that is the negation of not P, or the double negation of P, but we're going to go from not P to not P. So the negation of this guy. So if not P is false, not P is true. And if not P is true, not P is false. Now here's one of the cool things about truth tables is if two statements share the exact same list and order of truth values. So in this case, P is true, false, and not P is true, false. Those are what we call logically equivalent statements. So because the truth table is always the same for every possible value of the proposition in there, those must be the same. That's the power of logic, is I can say that, period, without a doubt, not P is always the same as P. Now, some of you guys might be thinking, well, two rights don't make a left. This is true. But left is not the opposite, the negation of right. Turning right, the negation of that is not turning right. Doing anything that is not turning right. Okay, so that is the way our initial look at truth tables works. So if we only have one proposition, one statement, the only effect we can have on it is to consider it or its negation, its opposite, it's not. When we have more than one proposition, which we often get in sentences, because people will say, you know, New York is the capital of New York and Austin is the capital of Texas. Wow. Sorry, my video's freaking out. You know what? I'm going to pause it because of that and I'll record a new video.